rusty lump pulled from the sea held technology humanity wouldn't reinvent for 2,500 years. In 1901, sponge divers off the Greek island of Antikythera pulled something from a Roman shipwreck. It looked like a corroded lump of bronze, roughly the size of a shoebox. Shh! Nobody knew what it was. It sat ignored in an Athens museum for 2 years before anyone looked closely enough to realize they had found something impossible. Researcher Valerio Stice noticed something in 1902. Inside the crust were gears, actual meshing bronze gears cut with triangular teeth at a precision that should not have existed in 100 BC. The ancient world was not supposed to have gear work, but this device had at least 37 interlocking gears, all working in concert. Scientists spent decades trying to reverse engineer it. X-ray imaging in the 1970s by Derek DeSala Price revealed the true scale of the engineering. The device tracked the sun, the moon, and 5 planets simultaneously. It predicted solar and lunar eclipses with eerie accuracy. And then everything changed when researchers found the back panel. The back panel contained 2 spiral dials. One tracked a 19-year lunar cycle called the Metonic cycle, used to align the solar and lunar calendars. The other tracked a 223-month eclipse prediction cycle called the Saros cycle. Turn the hand crank forward, and the device told you exactly when the next eclipse would occur, months or years ahead. But predicting eclipses was only half of it. The front dial modeled the irregular motion of the moon, a problem so complex it involves what we now call the first anomaly of the moon. The Greeks solved it mechanically using a pin and slot device inside one gear. This single mechanism forced one gear to speed up and slow down, mimicking the moon's actual elliptical orbit. The device also tracked the 4-year cycle of the Pan-Hellenic Games, including the Olympics. It showed the user which athletic games were coming and when. This was not just astronomy. This was a portable, hand-cranked almanac covering celestial events, religious festivals, and athletic calendars simultaneously. Nothing like it appeared again in human history until mechanical clocks in 14th century Europe. So who built it? The mechanism contains inscriptions referencing Corinth and its colonies, pointing towards Syracuse in Sicily. Syracuse was home to Archimedes, possibly the greatest engineer of the ancient world. Some researchers believe this device descended directly from Archimedes' workshop, built by his students decades after his death in 212 BC. But that link has never been proven, and the true maker remains unknown. In 2021, the University College London team used 3D computer modeling to reconstruct the entire front panel for the first time. Their model showed all 5 known planets, Mercury, Venus, Mars, Jupiter, and Saturn, displayed on concentric rings, driven by the same hand crank. One device, one turn, showing the entire known cosmos in motion. The scale of the ambition is almost incomprehensible. What the antikythera mechanism proves is not just that the Greeks were clever. It proves that an entire tradition of sophisticated mechanical engineering once existed and was completely lost. We have no other examples, no workshop notes, no teacher-student lineage we can trace. A technology tree that took 1,500 years to regrow was sitting on the seafloor off a Greek island, nearly thrown away as worthless debris. That changes everything we think we know about ancient civilization. The antikythera mechanism also held a mirror arrangement that could predict eclipses far into the future. By combining the Saros cycle with its own gear ratios, the device could estimate when the moon would align with the sun or Earth to produce a solar or lunar eclipse. In practice, ancient sailors could look to the back of the machine to know if a dangerous eclipse might cross the horizon on a given day. This predictive power would have saved countless voyages from the terror of sudden darkness. It also gave astronomers a tool to chart celestial events with a precision that rivaled, and in some aspects surpassed, the ancient Greek ephemerides. Beyond eclipses and cycles, the antikythera worked like an early computer for the orbit of Jupiter's Galilean moons. When observers noted the infant's slight wobbles, the machine could translate those movements into a series of teeth on its wheels. This meant the Greeks had a ready-made algorithm for a set of celestial bodies that right now play a dominating role in modern physics. And the very fact that they encoded such information shows a mechanistic worldview that predated the notion of equations by more than 1,000 years. It was a handcrafted analog computer built to track the heavens in a way we can only now appreciate. hierarchy, the sun at center, moon, earth, and the debated world of planetary bodies around them. The hidden inscriptions indicate that the mechanism might have been used as a teaching tool, showing students how the motions of these heavenly bodies nested within one another. Some scholars argue this knowledge may have formed the basis for later Greek philosophical thought on the uniformity of celestial motion. In simple terms, the antikythera device reminds us that the Greeks wanted more than just numbers. They sought to weave a narrative of the cosmos that could be felt through metal and gear. If a device this advanced was completely lost, what else did the ancient world know that we haven't found yet? That question gets even more disturbing in our next video. Subscribe so you don't miss it.